All is lost. There's something on the screen.
All right, here we go. So trig proofs. Oh, see, I just knew it. I knew I was going to say the word proof, and then you were going to have some vitriolic reaction to it, all right? Okay, you're 2 years more mature than you were when you did proofs in geometry, so I'm sure that you can handle it. You've been doing trig proofs. We just haven't been calling it that. The last 2 lessons have been trig proofs. So don't think it's any different than what you have already been doing. This is the way I like to think of a trig proof. To me, it reminds me of when I need directions to go someplace. Okay, so here, this morning.
Is that to your house?
No, this is from here to Taco Bell. Okay, but a different Taco Bell, the one up in Downey. Come on. All right. What?
That's where your dog is.
Okay, so you see we've got a starting place. So when you need directions, it needs to know where you're starting, and what else does it need to know? Where you're going. Okay, and then what will it provide for you? How to get there, the directions in between. Okay, is there more than one way to get there? For sure. Okay, often there are multiple ways to get there. There's usually one that is the best in terms of time. It's the most efficient. Okay, so they'll show me that in blue. But there are alternate routes, which are in gray. All right, and those could get me there just the same way, just as well. And it'll list for me the steps on the side. A trig proof is the same way. You've got where you're starting, which is the complicated problem, the more complex problem. You've got the end, which is the simplified version of the problem. The proof is the steps in between, where you are telling explicitly, pull out of your driveway and turn right, okay? Replace this with that in a trig proof. So you're just giving each step separated by an equal sign. You've been doing a trig proof for the last 2 days. We're just calling it trig proofs now, okay? So that's kind of what it's like. The words you're going to see that clue you in to the fact that you are doing a proof are words like this. Well, clearly prove, but you're going to see words like verify. Okay, verify is a proof type of word. So here's going to be the question. Verify. Cos cubed x parentheses by 1 plus tan squared x parenthesis equals cos x. So in this kind of question, you have where you are, the beginning. You have where you need to end up. Where do we need to end up?
Cos x?
We need to end up at cos x. Okay, we need to get all the way through a question, so we end up at cos x. So it's actually easier than the homework you've been doing because you have both the beginning and the end. Your job is to provide the steps in between. All right? So I'm just going to make my screen a little bigger. We're not going to look at cosine right now because we know that that's our ending spot, and we're just going to get started, all right? Give me the first direction. What do I do first? I'm backing out of my driveway. What do I do? Okay. All right, I heard FOIL, which would be an option. I heard, I don't know, something else. Okay, we're looking for replacements probably are going to be some of the best things we're going to want to do. What replacement can I do? All right, 1 plus tan x, that's my replacement. So my first step in the directions of what to do is to keep cosine, but replace 1 plus tan squared x with the identity secant squared x. All right, that's the first step. Next step.
Could we do the put 1 over cosine?
Okay, we want to do a replacement again. Remember, we don't replace cosines and sines. Those usually stay put. But we will replace other things. And so secant squared would also get replaced. And I'm going to have cosine cubed. And in the next parenthesis, what will I replace 1 over secant squared with? 1 over cosine squared. Okay, and when I do that replacement, now I've done the replace, and I'm ready to reduce. Okay, replace, replace, reduce. So I am ready to reduce. When I think about reducing, you might want to think about it this way. The first parenthesis has 3 cosines in it, cos x, cos x, cos x, because that's what cosine cubed means. The second parenthesis has 2 coses in it, cosine and cosine. And so the 2 from the bottom reduce 2 from the top, and how many are we left with? 1, which is cos x, which is where we were trying to get to. We have arrived at our destination. You are here.
Do you want us to write out those cosines?
Say that again?
Do you want us to write out those cosines?
You don't have to, just now that was just for helpful. All right, let's try another one. This is verify. You might see an example that says prove, but it's the same idea. All right, prove 1 minus sine x, 1 plus sine x, over sine squared x. Prove that that will turn out to be cotangent squared x. So you have the beginning of the directions, you have the destination of where you want to end up. Your job in doing a proof is to provide the step-by-step directions to get you from one place to the next. So I'm just gonna make my cotangent kind of disappear so I can focus on what I need to do. All right, give me some directions. What could I do first? Replace? Replace what with what? Can I turn 1 plus sine x into cos x, or okay, it's not squared, so I can't. How about 1 minus sine squared? Is that going to change into cosine squared? Okay, I need to FOIL. My first step is FOIL. Okay, my first directions, okay, back out of your driveway and please FOIL. All right, FOIL will be first. So 1 plus sine x minus sine x minus sine squared x. That is all over sine squared x. Okay, what is the next legal thing that you're going to tell somebody to do? Okay, the top can be simplified, that the middle 2 terms, okay, so now I have 1, and then I have minus sine squared, and it's over sine squared. Okay, my next move is going to be to reduce the sine squareds, and my answer is 1, and that's my end of my proof.
What about the negative?
Oh,
Wait, that's
Wait, no, you
wrong.
can't.
oh, good. I'm glad. All right. All right. First of all, that's not where I'm supposed to end up. Where am I supposed to end up? At cotangent squared. So what I can't have you do is do illegal math like that and then write, I end up with cotangent squared. She's not going to notice that I just did something totally illegal and ended up with cotangent squared. Okay, I can't reduce the green parts what I did. Why not? It's not multiplication. That's a subtraction problem. You can't reduce a subtraction problem. And I saw some of you try to do that on your quiz. Okay, you cannot reduce addition or subtraction. So, that is not valid for me to do here. So I can, what would be the valid thing for me to do? All right, I can replace, and I want to replace 1 minus sine squared with cosine. So that will be cos squared on the top, and I still have my sine squared on the bottom, which I didn't reduce. Now that is replaceable with cotangent, and now I've arrived at my destination legally. Okay, so the pitfall of knowing where you're supposed to go is giving bad directions to get there. All right, so because if I actually follow the directions you give me, I may end up driving into the riverbed or something like that. So I don't want to do that. Yes?
So when you have a squared x over squared x, they don't reduce.
The squareds don't reduce. No, because they're powers, and that doesn't work that way. All right, last one. All right, verify that cotangent x plus tangent x equals secant x cosecant x. So an addition turns into a multiplication. That's what you're supposed to verify. That's what you're supposed to prove. The addition of two things turns into the multiplication of two other things. So how can we prove that that works? All right, well, let's, we know our beginning, so give me my first step. What can I do with cotangent and tangent? All right, this is cosine over sine, and that's sine over cosine. So great, then I can just reduce the sine here and the cosine there, and I have 1 plus 1, and the answer is 2.
No, that's illegal.
Okay.
That's not right.
That is not right. But it always happens. Okay, so whoops, we're in the riverbed, we're in the ditch. Okay, how do you add up things? Well, let's look at arithmetic. Cosine over sine plus sine over cosine. Let's pretend that that's 2 over 3 plus 3 over 2. In regular math, how do you add those? You don't just add and say 5 over 5. Okay, let's just finish this. What do I need? Common denominator. So what does the 3 need? A 2. What does the 2 need? A 3. So that's going to be the same here. What does the sine need? A cosine. On top and bottom. That's how common denominators work. What does the cosine need? A sine. That is on top and bottom. So what I actually legally end up with is cosine squared over sine x cos x plus sine squared over sine x cos x. Now I have a legal common denominator, which I can add together and combine it. And when you combine it, what do you notice about the numerator is replaceable?
Oh, with 1.
It is. So the numerator is replaceable with 1 because it's cosine squared plus sine squared. And we have 1 over sine x cos x, which can be flipped back into cosecant and secant. And we have our destination. We arrived.
Wait, well, how did you flip it?
Well, 1 over sine x by itself is cosecant, and 1 over cosine x by itself is cosecant. Isn't it okay if I just add an extra 1? 1 times 1 is still 1, right? And so 1 is over both of them.